We know that the cube root of 8, or 8 to the power 1/3, is equal to 2. But did you know that the cube root of negative 8 is not negative 2? Consider the equation x cubed equals 8, which we know has three solutions, not just the obvious solution x equals 2. We'll solve this using de Moivre's theorem. And the three solutions are these. I'll refer to x1 as the primary solution. The primary value of the argument in this case is 0 degrees, and the other two solutions are generated from this solution by adding multiples of 120 degrees to the argument. So we say the cube root of 8 is 2. Now consider x cubed equals negative 8. It seems we can just say x is negative 2 because negative 2 cubed does equal negative 8, but negative 2 is not the primary solution. Let's solve it again using de Moivre's theorem. And the three solutions are these. The primary solution is x1 equals 1 plus I root 3. The primary value of the argument in this case is 60 degrees, and the other two solutions are generated from this solution by adding multiples of 120 degrees to the argument. So the cube root of negative 8 is actually 1 plus 1.732i and not negative 2. This answer can be verified on the graphics calculator. Similarly, let's consider x to the 4 equals 1 and solve this by de Moivre's theorem too. This is the normal setting out, and of course we get 4 solutions, and these are the 4 solutions. The primary solution is x1 equals 1, and so the fourth root of 1 equals 1. Compare this with x to the 4 equals negative 1. Again, by de Moivre's theorem, we get this working, and these are the 4 solutions. Notice that none of these solutions is a real number. The primary solution is the first one, x1, so that the fourth root of negative 1 is equal to this value, which can be verified on the graphics calculator. Now consider x to the 5 equals 32, which will have 5 solutions. Again, by de Moivre's theorem, these are the 5 angles, and the 5 solutions are these. So simply we say the primary solution is x1 equals 2, and so the fifth root of 32, of course, is 2, which obviously can be verified on the graphics calculator. However, consider x to the 5 equals negative 32. Again, solving by de Moivre, these are the 5 angles, and these are the 5 solutions. The primary solution, x1, equals 1.62 plus 1.18i. So that the fifth root of negative 32 is 1.62 plus 1.18i, which also can be verified on the graphics calculator. In conclusion, the equation x to the 5 equals negative 32 is not the same as the equation x equals the fifth root of negative 32. The equation x to the 5 equals negative 32 has 5 solutions, but x equals the fifth root of negative 32 only has one value, that is, the primary solution. Similarly, the equation x squared equals 9 has 2 solutions, x equals positive 3 and negative 3, but x equals the square root of 9 only has one value, x equals 3, the primary solution.